Here's how to run the color tracking version 1 software on your SCUTTLE Robot. So this is the file here on the left hand, and you're going to grab that from the GitHub here under Python color tracking version 1.py. The best way to add this into your directory is to click the raw button. You can highlight all the text with Control A on your keyboard, then Control C to copy. Then you can right click here in Cloud9. You're going to do new file, name it name.py, not actually, name it the same as the name in the GitHub. Then we're all going to be on the same page. You go into here, Control V to paste it. Then we're going to Control S to save the changes. And then we're going to come over here to your terminal, and you're going to ask your robot to run the code. So in this case, I've already got the code in color tracking version 1.py. Hit enter. It's going to ask for the password. And then you'll see that it takes a little bit of time to load the libraries for color tracking. It's going to load the libraries in general that are right here, and then it's going to load the libraries for RCPY. And then your robot will be running the code, and it won't give you any indication that it's running on the terminal. It's just ready. This corrupt JPEG data, that might be one failed shot, one failed frame coming from the USB camera, but it should be ready to run now. And we'll show you now. We'll use the basketball as the target in front of the camera, and we're going to see some output. I got the basketball. Okay. So we're seeing too far. That means that we're seeing fewer pixels that are within the color range specified than we want to see. And when we approach the ball closer, then we'll see more pixels. The radius will be increasing, and then we can get the too close condition. Go ahead and let's move it closer. Okay, so now we're intermittently getting too close. The testing condition right now is that the lighting is not the same in this room as it was in the location where we were doing our calibration. So we're not capturing as many pixels as we expected to see, and the too close condition is hard to achieve. But the details of the program will be explained separately, but basically too close is a condition where you want to have the robot backing up and then maintaining a safe distance from the target. I guess we can show left and right too. So left hand, if we move the target to the left, turning. Turning means that it doesn't matter if it's too close or too far. I need to move my robot in order to get the target back into the frame. And in this case, we're going to the left because the X values are less than the X value of pixels that would indicate the center of the screen. And I think we can go to the right hand side and think over 150 or so. We'll go to the far right hand side. Okay. On the under 200 but over 100, you can view the values in the code to check out how the calibration is done. But there's basically an X value that's indicated as the center pixel, and then the turning will vary based on being too far left from that or too far right from that.